So good day. So today we will be solving another problem about concerning strain. Okay, so we will solve, okay, in this video we will solve 2.44. So the figure shows the cross-section of a circular steel tube that is filled with concrete and topped with a rigid cap. Calculate the stress in the steel and in the concrete caused by the 200 kip axial load. Use EST is equal to 29 times 10 to the 6 psi and ECO equals to 3.5 times 10 to the 6 psi. So, okay, so here is the figure. Okay, so logically, the EST is the modulus of elasticity of steel and ECO is the modulus of elasticity of concrete. And okay, in this figure we would see, okay, that it carries 200 kips, and this is what we call a composite material, okay, which is composed both of partly of steel and partly of concrete. Okay, so without further ado, we will go to the solution. Okay, so I have already prepared here the solution, okay, for 2.44. So I just redraw the figure and then put all the given. So here it carries 200 kips, and inside it is composed of concrete and outside it is composed of steel. So for concrete, its diameter, okay, from the figure, okay, just copied it. So the inner diameter is 6 inch. For steel, it has the outside diameter of 6.5 inch, and it is hollow in the middle because it is composed of concrete instead of steel. So it has outer diameter of 6.5 and inner diameter of 6 inch. Okay, so here, so logically these 200 kips will be carried by both steel and concrete. Okay, a portion of these 200 kips is to be carried by steel, and a part of that 200 kips is to be carried by concrete. So therefore, the P steel and the P concrete should be equal to 200. So we transpose, so we get that the P concrete is equal to 200 minus P steel. Okay, so therefore we can use this following. Okay, so here the next step I do is I get the deformation of steel. Okay, so here, so from the figure, we refer to the figure, the steel is a hollow material in which 6.5 inch in diameter of its outside diameter, and its inside diameter is 6 inch. Okay, so we know that the equation for the deformation is equal to PL over AE. So that's why and it is we concentrate first on steel, so P steel times L over A steel times E steel. So the L here, okay, so since it is not given, so we just put it L. So P steel times L, the area is circular. Okay, so it says in the problem that it is a circular steel tube. So and the area and the equation for the area of hollow is pi over 4 multiplied by d outside diameter minus inner diameter. So the outside diameter is 6.5 and the inner diameter is 6, and then multiplied by E. So the E for the steel is 29 times 10 to the 6 psi. So we get the equation for deformation of steel. And here we comes for the deformation of concrete. So the deformation of concrete is equal to the P concrete times L over AE. Okay, so the same, similar to steel. So it's also PL over AE, which is the general equation for deformation. Okay, so we represent all values for concrete. Okay, P concrete multiplied by L, they have the common L but it is not given, so we take it as it is. And then over the A concrete, or the cross-sectional area of concrete. So here, it has a diameter, it is located at the middle, it encased inside the steel. So therefore, okay, so from the problem it says it's circular steel tube, a circular tube, so therefore in the it will be circle, and the area of the circle in the is equal to pi over 4 times r squared, and the radius of this concrete is 6 inch, so pi over 4 times 6 squared. And then we substitute the ECO, or the modulus of elasticity of concrete, which is 35 times 10, 33.5 times 10 to the 6 psi. So we get that one, that equation. And since we know that from the previous equation we formed that P concrete is equal to 200 minus P steel, so we get this one. Okay, 200 minus P steel multiplied by L over pi over 4, 6 squared, multiplied by 3.5 times 10 to the 6. Okay, so but somehow, by just looking upon the figure, so it is logical that the steel and the concrete should settle or deform the same in order to form an equilibrium. So since the deformation at steel is equal to the deformation at concrete, so we get we equate this one with this one. Okay, this equation and this equation. So since deformation of steel is equal to deformation of concrete, so we substitute this one and this one to this and this respectively. Okay, so we equate. So okay, so this is, it's their equivalent for steel and therefore concrete respectively. So here, so from that new equation we formed, we equate them. So therefore, by cross multiplication, so we multiply this by this and this by this, so we get this problem. And since they have the common variable L, so we can cancel out the L. Okay, so here I simplified those that contains L and those who don't. Okay, so from this one, all of them contains L, so therefore we cancel all of them. So the only variable that is left is P steel. So from this figure, from this equation, we get P steel is equal to 117.982 kip. So this is the P steel. And then we substitute this computed value to this equation from the first equation we formed to get the P concrete. So the P concrete here is 82.018 kip. So therefore, okay, so let's trace back. The P steel is 117.982. This is the part of the 200 kips that is carried by steel. And this one, P concrete, 82.018 kips, is the one that is carried by the concrete. So if you add this one, 82.018, with the P steel, it should be equal to 200 kips. So if we add them, okay, so just check 117.982 and 82.018, so we get 200 back. So therefore, we might be correct. So the final, okay, so it is being asked to calculate, okay, so we get to problem, calculate the stresses in steel and in concrete. So from that, we get the P concrete and the P steel. So we just simply divide it by the area, their area respectively. So therefore, the stress in steel is equal to P over A of steel. So the P of steel is 117.982, so you divide it by the area. So since the area is pi over 4 multiplied by the outer diameter, which is 6.5 squared minus the inside diameter squared, in inch squared. So therefore, we get that the stress in steel as 24.035 KSI. Okay? So since the load tends to compress the system, so therefore it is compression. So 24.035 KSI or 24,035 PSI in compression. And we have the stress in concrete, which is equal to P concrete over the A concrete. So we computed the P concrete as 82.018. So you divide it by the area, which is pi over 4 times 6 squared, since it is circle, in squared. Okay, 6 is the diameter of concrete encased inside the concrete steel tube. So the stress in concrete is 2.901 KSI or 2,901 PSI. Okay, so I hope you learned something from this example. So thank you for listening.